Good morning. Welcome to a new video class. In this class, I will discuss about the energy flow diagram to the earth. This is a topic in the renewable energy paper of physics in the sixth semester of BSc students. Therefore, the content of this topic is purely within the limits of the syllabus of the elective paper in the sixth semester, that is the renewable energy. This topic is in the unit 1 of the renewable energy. Right. This is what is this one? The topic is energy flow diagram. Right. Actually, in the beginning, we have to say that sun is the source of the energy source of the earth. Earth and its components, that is its nature, its atmosphere, and each and every constituent part of the earth is energized by the radiation received from the sun. Therefore, sun is the source of the energy for the earth. Now, in this topic, the essence of the topic is energy flow diagram of the earth means how much energy will flows towards the earth from the sun in each and every second, and how much energy will go back from the surface of the earth continuously in each and every second, and how these two are balanced, and their well balancing. Well balanced means the incoming energy is equal to the outgoing energy. Incoming energy, if the incoming energy is equal to the outgoing energy, then a balanced atmosphere, a balanced climate, and a well balanced conditions are established on the surface of the earth as well as in the atmosphere of the earth. That's why this is the main aim of this topic. What is the main aim? The quantity of the incoming radiation and the quantity of outgoing radiation, how these two are balanced, in which way they are goes towards the earth and goes away from the earth, and these things are well explained as far as this particular topic is concerned. That is what is known as the energy flow diagram. Energy flow diagram. Okay, right. Just now I said that the weather and the climate on the earth are dictated by the amount of incoming energy from the sun. Okay, very clear. Earth's energy budget explains that if the incoming and outgoing radiations are equal, then the climate is in equilibrium. Then the atmosphere is in equilibrium. This balance is achieved or not achieved depends how this incoming energy interacts with the earth and objects on it through different phenomena such as scattering, reflection, absorption, and energy transformation. Okay, this balancing of incoming and outgoing will be achieved or sometimes not achieved. Okay, totally depends upon how the earthly objects interact. Okay, the interaction of earthly objects with three or four phenomena, that is the scattering, reflection, absorption, and energy transformation. Energy can be converted. Yes, when once the solar radiation comes into the earth, it will be converted to the other forms. It is transported, and also it is stored in variety of forms. Overall, how energy acts once it has reached the earth plays a significant role in Earth's climate. Energy flow. Energy flows are the energy transformations. Energy flows means they are the energy transformations and movement that occur once energy has reached to the earth. Once energy is reached, then it will be transformed. It will transfer from one form to the other form. Okay, and it creates some moments. Okay, mechanical movements and other things. Okay, all these things will be okay there as far as all these things are known as the energy flows. These flows describe how energy is distributed and how it is interacted with objects, determining certain climatic properties. Okay, depends upon how these energy flows will distributed and interacted will decides the climatic properties on the atmosphere, in the atmosphere of the Earth. Actually, 30% of the solar radiation is immediately reflected back. Only 70% moves towards the Earth in different forms and paths. Right. Actually, sun is the major source of energy. Sun is the major source of energy for the Earth, and of course, 0.03% of the radiation, so energy will come from the other planets, other astronomical bodies and stars, which is negligibly small. That's why we will simply say that the energy is the only source of Earth. Right. Next, this makes the solar flow the most dominant energy flow. Actually, the solar flow is the most dominant energy flow for the Earth. In total, 1,74,000 terawatt of power. How much? 1,70,000 terawatt of power will goes towards the will moves towards the or will flows towards the Earth. This energy is equal to the energy produced by 4 million tons of oil in 1 second. Okay, the energy produced by 4 million tons of oil in 1 second is equal to the energy flows towards the Earth from the sun. Okay, that is 1,74,000 terawatt. The Earth then radiates power from all the flows back into the space in the form of thermal radiation. Right. Then the Earth radiates power. The amount of radiation received by the Earth after it is transferred, after it is converted and everything, later ultimately it transmits back the energy in the form of thermal radiation. Incoming is electromagnetic radiation, outgoing is thermal radiation. That is very, very important that you have to remember. Incoming radiation is electromagnetic radiation in the form of mostly visible infrared rays and a slight ultraviolet rays component. Okay, that is the EM, electromagnetic radiation. Outgoing radiation from the surface of from the Earth is thermal radiation. Okay, one is electromagnetic radiation, the other one is thermal radiation. Incoming is electromagnetic radiation, outgoing is thermal radiation. Right. Earth stays nearly totally balanced in terms of temperature due to how the flow interact with each other and how solar energy reaches the Earth. Okay. The means and the ways with which the solar energy are consumed and flows and interacted will decide the balancing and a livable temperature that is on the surface and the atmosphere of the Earth. But this is due to the Earth's energy. This is what is known as the Earth energy budget. Right. Increasing of greenhouse gases like carbon dioxide and methane. The greenhouse gases and the carbon dioxide and methane leading to the slight less heat being radiated into the space. Okay. Whatever the thermal radiation that was radiated by the Earth towards the space will be slightly decreased by greenhouse gases. Therefore, what will happen? The difference of amount is 1 watt meter square. This much of thermal radiation will again heats up the Earth surface and atmosphere. Therefore, Earth surface and atmosphere will be, the temperature will be slightly increases. So, okay. Whatever actually that is needed. That's why it is known as this is known as the heating up of raising of the Earth's temperature and its atmospheric temperature, which is known as the global warming, which is a very bad climatic condition. Right. Now, this diagram actually shows the incoming and outgoing. What is incoming? Electromagnetic radiation. How much? 1.27 10 to the power of 17 watt per second. Okay, in which 34%, that is 6 in 10 to the power of 16. I will say it as 0.6 in 10 to the power of 17 will be immediately reflected radiation, immediately reflected back. How much it is? 34% is reflected back. 34% is reflected back in the form of again electromagnetic radiation. Right. What is the remaining 66%? In which 42% is okay direct heat production in the atmosphere. Okay, it is directly heat produced in the atmosphere. Okay, it will go to the thermal energy source from the earth. Right. Next, the other component is 23% that is stored in water vapor, stored in the form of water vapor. Okay, that water vapor also radiates and that is also goes for the thermal component. Okay, some value that is 1%, less than 1% will be wind water waves. Okay, that is absorbed by the wind water waves and that is also okay reflected in the form of thermal radiation. Okay, only the small value that is 4 into 10 to the power of 13 will goes to the plants and animals. Okay, okay, plants and animals, some of the energy is radiated back, and when plants and animals are okay becoming fossil burning materials in the cluster of the earth, it will be used by the human consumption. Human also consumes nuclear energy. Human also consumes geoheat. Okay, the total human consumption is 1 into 10 to the power of 13, that is 0.006. Certain part of the thermal geothermal also goes directly to the heat energy, and now human consumption, animal plant consumption, okay, wind water waves, storage in water vapor, all the four components will go as a thermal energy, and direct thermal heat is 42% and total thermal energy radiated back is 66%. Therefore, how much energy that is radiated back from the surface of the earth, that is 1.6, 1.1 10 to the power of 7 watt. How much it is? 66%. In which form? In which way? Thermal radiation. What about the other value, that is 34%? What is that 34%? It is immediately reflected. It means that the electromagnetic radiation is immediately reflected in the form of electromagnetic radiation back, that will account 34%. Okay, that's why out of 100% that comes in the form of electromagnetic radiation, 34% will be reflected back in the form of electromagnetic radiation, but remaining 66% that is consumed and that is converted and okay all the forms and all the components of the earth, and ultimately the 66% of the remaining part will be reflected back into the space by the earth in the form of heat radiation. This is what this one energy what is this one energy flow diagram to the earth, energy flow diagram of the earth. Okay, right. Okay, I will account for this one in the other way also. Incoming solar radiation is equal to 340 watt per square meter square. 340 watt per square meter square, like it is 100%. In which 29%, that is 30% is reflected back. Reflection by the clouds and atmosphere 23, and the earth surface 7. These two will together will give 30% or 29%. 23 is absorbed by the atmosphere. Atmosphere will absorb 23%. 48 is absorbed by the earth surface. Okay, that's why okay the incoming will be okay 29 directly reflected, that is 30 is directly reflected, 23 absorbed by the atmosphere, 48 absorbed by the earth surface, total 48% is accounted by this one. Right. Now the energy that radiates back into the space, that is earth surface releases 5% and 5% of the energy into atmosphere by convection and 25% by evaporation. 5% and 25%. Okay, these two are in the form of evaporation. Right. The heat directly leaving earth surface, by the higher thermal radiation, okay, through the atmosphere, which is known as the atmospheric window, is equal to 12%. 50% of the heat is emitted by the atmosphere. 50% of the heat is emitted by the atmosphere, of which 9% is emitted by the clouds. Total outgoing radiation is 71%. Total outgoing radiation is 71%. Okay, in which 5 and 25% are reflected back. Okay, that's why this is 70 plus this is 30. Okay, this is the energy that goes out goes back okay from the earth. Okay, as I explained by means of the diagram also. Right. For the sake of students' convenience, I will upload now the students' material for their preparation. Okay, which will use the energy flow diagram. Energy flow diagram. This one. Just now I said, okay, whatever I said, I will be again kept here. That the sun is the energy source for Earth and its constituents. The energy received by the Earth from the sun will be distributed to the Earth's components of the climate system. Therefore, the climate of the Earth is powered by the sun, and it is called the Earth heat engine. It means that the Earth is a heat engine. Earth is a heat engine. There is a input to source, and it will, okay, there is the output for the this heat engine. That's why totally the Earth will act as a heat engine. The system of Earth is made up of water, ice, atmosphere, rocky crust, and living things. The total energy received by the Earth and the radiated energy by the Earth back to the space are shown in the energy flow diagram. That is this one, which is already shown to you with the same figures and same values, same figures and same values. Okay, this is what this one. This is about what this one, energy flow diagram to the Earth. Okay, right. See you in the next class.